Lesson 48, Derivatives of Trig Functions, and Summary of Rules for Derivatives and Differentials. So, we know derivatives of two trig functions right now, yes? Derivative of sine of x is cosine of x, and derivative of cosine of x is negative sine of x, yes? Those two are the two that we've learned at the beginning. We're working with them. We know them. We use them. What we're going to look at today is some ways that, honestly, what it'll come down to, if you ask me, memorize some of the basic trig functions. Okay? You're going to want to memorize a lot of the basics. However, as long as you know things like sine and cosine and some of your other rules, like the cofunction identities or Pythagorean identities or things like that, you can find other ways to find these. And that's kind of what we're going over today. But again, ultimately, you're probably just going to end up memorizing most of these. At least that would be my guess. So let's look at example 1 here. Use the fact that the derivative of sine x with respect to x is cosine x to find the derivative of cosine x with respect to x. Okay, so this is kind of going off of one that we already know. I shouldn't say kind of, it is. But we're using the fact of that we know the derivative of sine x is cosine x. Okay, and we're going to use that to find the derivative of cosine x. So let's start with cosine x. Okay. Cofunctions. Do you remember your cofunctions? What's the cofunction identity for cosine x? Does that sound familiar, guys? Now that he says it, at least.
There were like 3 different things going through my head, and I didn't want to guess because it never works well for me.
Okay, so we're trying to find the derivative of cosine x, right? So we start with y equals cosine x. According to our cofunction identities that we learned last year, these are cofunctions, okay? Y equals cosine x is equivalent to saying y equals sine of pi over 2 minus x, yes? Okay. Well, we're using the idea that we know the derivative of sine x is cosine x to do this problem. So we're going to take the derivative at this point. The derivative of y with respect to x, how do I usually write that? dy dx. Derivative of sine of something is cosine of something. So cosine of pi over 2 minus x times the derivative of something. Is there a derivative of the something that I need to worry about here? Yeah, what's the derivative of pi over 2 minus x? Well, pi over 2 is a constant, so that just disappears. The derivative of negative x is negative 1. So this is times negative 1. Let me rewrite that in better form and put the negative out front. So dy dx is negative cosine of pi over 2 minus x. Let's go back again via cofunction. What's the cofunction of cosine of pi over 2 minus x? Yeah, the negatives are right here, and the cofunction of cosine of pi over 2 minus x is sine x. So this is equivalent, again, to saying negative sine x. And this time it's because these two here are cofunction identities. Now, ultimately, We went a roundabout way, but what did I just show?
Why it works the way it does.
Okay, why it works the way it does. And I started with cosine, and I'm saying the derivative of cosine is negative sine. Okay, that's the proof that I was doing there. In that, and I'm going to write it here, the derivative of cosine x, so dx of cosine x is equal to negative sine x. By putting the dx out front, that is just saying, it's not saying take the derivative, it's saying the derivative of cosine x with respect to x, and then is equal to negative sine x. Okay? Now, the other ones we're going to look at are ones that you don't know yet. So we're kind of developing the derivatives today. As we look at example 2, use the quotient rule and the derivatives of sine x and cosine x, which we already know, right? To find the derivative of tangent x with respect to x. So the problem we're working with here is tangent x. I want the derivative of tangent x. Well, I don't know the derivative of tangent right now. Let me rephrase that. You don't know the derivative of tangent right now. Is that a better way to put it? What do we know about tangent, though? We know that tangent can be rewritten as sine x over cosine x, right? That's given knowledge at this point in your math life. We know the derivatives of sine and cosine, yes? Okay, so let's take the derivative now. Derivative of y with respect to x is dy dx. Derivative of sine x over cosine x. Well, it's a fraction, so we're using the quotient rule. Remember the quotient rule? Derivative of the numerator. So what's the derivative of sine x? Cosine x times the denominator, cosine x. With quotient rule, remember it is minus. Now it's derivative of the denominator. So derivative of cosine x, negative sine x, times the numerator of sine x, all over cosine squared x, denominator squared. Now, we've got to do some magic cleaning up, but then we're going to know the derivative of tangent. Let's see, how's this clean up on top? dy dx, cosine times cosine, cosine squared x, minus negative, so plus sine squared x, all over cosine squared x. What do you know about your numerator? My numerator is 1 because of a PI, Pythagorean identity. Sine squared plus cosine squared equals 1. So I can rewrite this as 1 over cosine squared x. One more step, and that's how we usually think of the derivative of tangent. What is 1 over cosine squared x equivalent to? Secant squared x. The reciprocal of secant is cosine or vice versa. So dy dx is secant squared x. So what did we just learn? The derivative of tangent x is secant squared x. My opinion, stick it in your memory. That's easiest. That's what you're going to want to do. However, technically, if you get in a high stress situation and you forget it, could you work with the whole sine over cosine thing? I mean, that's technically, a way you can do it. My opinion, though, memorize it. Okay. Ready for the next one? This time, I believe, aren't we doing cotangent this time? Yep, same plan. Quotient rule, derivatives of sine and cosine, but this time we're finding the derivative of cotangent. So, starting with cotangent, y equals cotangent x. What do you know about cotangent x? Okay, this time it's cosine x over sine x. Same old quotient rule. dy dx close. Okay. Get your guesses in here for what you think the derivative is going to be. Okay. What's the derivative of cosine x? Derivative of the numerator. So derivative of cosine x is negative sine x times the denominator of sine x minus, because it's quotient rule, now it's derivative of the denominator, so derivative of sine x is cosine x times the numerator, cosine x, all over sine squared x, denominator squared. Okay. This time, what's my numerator look like? Negative sine squared x minus cosine squared x all over sine squared x. Thoughts on what I need to do with the numerator to make it work this time?
It's two, like those two pieces are subtracted to the other side of the Pythagorean identity, so you can just subtract the one to the other side.
Okay. I was just thinking factoring a negative 1 out. It all goes to show there's multiple ways to get somewhere, right? I was thinking, and it's a difference of how brains work. My brain says I see that they both have a negative in them. And so, I mean, I see what you're saying too. I don't know which one's easier, but I was saying factor out the negative 1. And then if you factor out negative 1, it's sine squared x plus cosine squared x, right? All over sine squared x. So then, sine squared plus cosine squared can be replaced with 1. Negative 1 times 1 is going to make my numerator negative 1. So I have negative 1 over sine squared x. What do you know about negative 1 over sine squared x? This time the reciprocal is cosecant, and there's a negative. So negative cosecant squared x. I'm guessing you guys could have gotten the cosecant squared. That seems pretty logical. Did you figure out that it was going to be negative, though? Okay, halfway through the problem, in other words. Makes sense. Okay, so I'm going to write out that d dx, the derivative of cotangent x, is negative cosecant squared x. And again, I'm just trying to get these summarized for you so that you can see the rules right there. Well, we've done 4 of our 6 trig functions at this point. You already know sine and cosine. We've done tangent. We've done cotangent. Now we need to do secant and cosecant. Okay, so we're using the quotient rule again. The fact that secant is the reciprocal of cosine to find the derivative. Quit cheating and looking ahead. Okay. I figured some of you guys had already looked ahead, so.
I just wanted to see if there was a second page, and then I saw that whole
I didn't even notice
there.
this. I was like, oh, look at that. We didn't have to do this.
Okay, so we're trying to find the derivative of secant. Y equals secant x. We know that secant is equivalent to 1 over cosine. So, quotient rule, here we go. dy dx. Derivative of the numerator. Derivative of 1? 0. Times the denominator, so times cosine x, minus derivative of the denominator. Derivative of cosine x, negative sine x, times the numerator, as is, all over, denominator squared, cosine squared x. Well, let's see what we got. On top, what's this clean up to be? Sine x over cosine squared x. The key that I look at in here, I see sine over cosine, right? And we know sine over cosine is tangent. And then that means there's an extra cosine on the bottom. So what I think of this is, I split it up. Sine x over cosine x. And then we have an extra cosine x in the denominator. So that's 1 over cosine x. I've just taken that sine over cosine squared, reorganized what I have, and then when we write that, we know that sine over cosine is tangent, and 1 over cosine is secant. Typical formation, the derivative of secant x is secant tangent, or tangent secant. So d dx, derivative of secant, is tangent x, secant x. I know some of you have already flipped the page and looked, but based on our progression today, can you guess what the derivative of cosecant is going to be? Negative what?
Negative cosecant or negative secant?
No.
No, I'm looking.
Would be negative.
Oh, cosecant.
Negative, because you saw what happened last time between examples 2 and 3. It became negative. Secant became cosecant. You guys are getting that. But tangent's not going to stay either. Okay? Tangent's going to become cotangent. Okay. Let's work it through real quick. We're looking at the derivative of cosecant. What do you know about cosecant? It's reciprocal of sine. So it's 1 over sine x. So, derivative dy dx equals derivative of the numerator 1, 0, times the denominator of sine x, minus derivative of the denominator, derivative of sine, cosine x, times the numerator of 1, all over denominator of sine squared x. clean it up, and I have negative cosine x over sine squared x. Last time I saw sine over cosine, so I saw a tangent in there. This time I see cosine over sine, so I see a cotangent in there. So I'm going to break it up. Negative of cosine x over sine x times another 1 over sine x. And so, negative, what's cosine over sine? Cotangent, times 1 over sine, which is cosecant. So, last learned one from the day, d dx of cosecant, the derivative of cosecant, is negative cotangent cosecant. Flip the page and take a peek if you haven't already.
Yeah.
And again, I think most of you had already taken a peek and, which is fine because I get it. We all always look, okay, is it 1 page of notes today, 2 page of notes? How bad does this look? Okay. It honestly took you guys a while to look, I felt like, today. Maybe someone looked and I just didn't know it, but you guys didn't let on.
At the beginning of class, I seen that looked like a bunch I have to memorize, so I was just kind of looking.
Okay. Well, summary of rules for derivatives and differentials. As you guys look at this list, we know these are all things we know at this point in our lives. Okay, or all things, let me rephrase that, we've learned. So, the very first one, d dx of c. So let's say the derivative of any constant is 0. Derivative of cu. That's saying the derivative of a constant times a variable to the first is just the constant. Derivative of u plus v. That's saying you do the derivative of u plus the derivative of v. The next one is the product rule. And that's where you're saying, okay, the derivative of u, keep the v. And then switch it. Plus, derivative of v, keep the u. And you've got the quotient rule there. We've got the power rule, where you move the n out front and subtract 1. Derivative of e to the x is e to the x. Derivative of natural log of x is 1 over x. Derivative of sine is cosine. Derivative of cosine is negative sine. And then those bottom 4. Those are the ones that we learned today, right? We're kind of adding those to your memory. Okay? That's what it comes down to. They are just good ones to know. They randomly come up in problems. And there's definitely some connections you can make there. Okay? The right column is just a different way of writing them. That's really all it is over there. It's writing them with the differential with it, so the dx or whatever it is with it. Okay?